Hello, I'm Robert Pastel. I'm Associate Professor of Computer Science at Michigan Tech. My students and I design and develop mobile web applications for citizen science projects. I'm joined by Dr. Ben Rudell and Dr. Michael Chester to introduce our project, FloodAware. But first, Ben, would you like to introduce yourself?
I'm Ben Ruddle, Professor and Director of the School of Informatics, Computing, and Cyber Systems at Northern Arizona University. I'm a data scientist and engineer who works on solving problems with connected systems, and these are problems that can be solved with better data. Water systems are my biggest focus.
And greetings, I'm Michael Chester, an Associate Professor of Civil, Environmental, and Sustainable Engineering in the School of Sustainable Engineering and the Built Environment at Arizona State University. I run a research lab focused on preparing infrastructure for the challenges of the coming century. I'm director of the Meta Center for Infrastructure and Sustainable Engineering and co-leader of the Urban Resilience to Extreme Sustainability Research Network.
Thank you. Why was FloodAware created? What are its goals?
Thanks, Rob. We recognized that there was a convergence of technological capabilities with the potential for making a leap in our ability to sense flooding and alert travelers to the hazard. Camera technology, the pervasiveness of cameras, image recognition, algorithms, including artificial intelligence, mobile phone technology, and citizen science have reached a point where there's the potential to harness these capabilities. While there are several efforts around the world to improve real-time flooding detection, there was not a systematic assessment of these technologies in the US, nor a concerted effort to communicate risks to individuals. This is where the FloodAware project comes in. Not only are we developing and testing the efficacy of several technologies, including cameras, image recognition software, crowdsourced reporting, and social media mining, we're also developing a back-end system able to take these feeds in, make sense of them, and provide the information to other services with an ultimate goal of real-time communication of flooding. Ben?
In order to pull that off, we need to have a lot of conversations and partners. Most of the public sector stakeholders in stormwater management and flooding are involved in this project, at least within the state of Arizona. We have the Department of Transportation, county and city stormwater engineers, and public safety officials, especially in the metro areas of Flagstaff, Phoenix, and Tucson. The National Weather Service's local forecast office is involved. There's also wildland, forest, and public land agencies, our local and in-state U.S. Geological Survey, and also some private consultants on hydrology and stormwater engineering, along with a number of conservation organizations that are concerned with streams and rivers. You also need to plan to scale up the project. So we need to have conversations with national flooding and hydrology agencies, those scientists and modelers, especially at the U.S. Geological Survey and NOAA's National Weather Service. There's 3 state universities in Arizona. That's Arizona State, Northern Arizona, and University of Arizona. And we also have university partners at Michigan Tech and the University of Buffalo who run the crowd hydrology and mobile hydrology citizen science systems. FloodAware is a great example of a 21st century interdisciplinary applied science and engineering project led out of a university, but serving the public. This is the sort of project that students and young professionals would be well served to get involved in, because we're doing data science, smart cities work, artificial intelligence, public policy, engineering, sensors, software, and earth science. Those are some of the most important topics, and that interdisciplinary convergence is something that young people need to learn how to be a part of.
What is the project actually doing?
The project team that Ben just mentioned, the researchers as well as the stakeholders, are co-developing camera, both photo and video, crowdsourced data, image recognition, and social media scraping technologies. These technologies will result in data streams that will be processed by a backend server that we call IFSON, the Integrated Flood Stage Observation Network. IFSON makes sense of the data streams, it stores them, and then makes them available for access by services that want to alert the public to flooding hazards. For example, we hope that the National Weather Service, maybe Google Maps might be interested in these feeds. Furthermore, the project involves hydrologists who are using the new data streams to assess their potential for innovating urban hydrological modeling of precipitation and flooding events.
How about FloodAware? What is it?
FloodAware is a data fusion system in the core technology. It brings together some of the existing observations and predictions on water depth and flooding into a single system and interface, and it puts those in the hands of public safety officials, engineers, and the general public in near real time while flooding and rainfall is happening. So to do that, we bring in citizen science reports, social media mentions, National Weather Service warnings and predictions, traffic and web camera data, which we read using AI image processing techniques, and also the hydrology monitoring gauge networks that are run by local and national agencies. We bring all that into a single server, and then in its final version, this is all going to be brought to you using a cell phone application. And that application will also let you report your own flooding observations where you are.
How will our project help with urban flooding?
We hope that the combined technologies create a major step forward in alerting people to flooding hazards and helping infrastructure managers respond to flooding. The FloodAware system with the IFSON backbone will create an important advancement in our ability to mitigate the impacts of flooding, which remains one of the most deadly weather-related hazards in the US and the world. It will create new insights into our urban systems at the interface of human and natural systems in a world where climate change impacts are becoming more severe.
Thank you, Mike and Ben, for explaining FloodAware. If you want to learn more about FloodAware, please go to floodaware.org.
Thank you.
Thank you.
Thank you.